Chapter 2, MIPS Assembly Language. In this chapter, I would like to give an introduction to MIPS Assembly Language. So here, let's look at the MIPS Assembly Language. So this language, actually, when you write it, you have 4 different things you need to remember. If you use the sharp sign or punch sign, it's for command, similar to Python, okay? And then you have label. Label usually used for the memory address, like when you declare a variable X or you declare a function, you usually using label. Directive actually is used to assign the data type, and then you have instruction. 4 different things important. And in my note, I use the gray color, red color, green color, and black color to show it. Okay. So programmer need to specify a data object that live in the data region, functions that you can call, something like that. Okay, so that's the MIPS language. This is simple starting point. So a instruction, usually you will write label, the name of the memory location. So usually label is like just like when you have X, right? You declare X, that X is the label. Or you declare an integer function F, that F is a label. Okay, and then memoric, this one is actually like add. Sometimes add, sometimes difference, and you have operand, and then you have command. Okay, so that's the instruction name. So we will see this later. Okay, just remember this is the instruction format. Okay, and label sometimes come with the memory. Sometimes you don't need it. Okay, so here we have a more detailed function, instructions, arithmetic, logic, data transfer, control, conditional branch, and unconditional branch. So I just leave it here. I don't want to go into detail. And there are 3 types of the instruction: R type, I type, and J type. J is for jump. So basically, J just need to jump to some target edges. So the edges is longer, number of bits is more. That's fine. I type is for immediate data, so it is edges or immediate data over there. And source register, target register. And actually, here is the R type. You have the source register, R register, the destination register, or something different R function. With this one is register to register operation. Is that okay? So C type, R, I, J, J for jumping, R for register to register, I for immediate. Okay. Now, MIPS instruction actually is quite easy already, but compared to the old time instruction set, they have maybe more than 10 type of instruction. So here is a program template. Your data segment, you put .data here. So this one signify, actually notify your data segment. And this text signify your instruction segment. So right here is all instruction. Right here is all data. And your main program is right here. You load 10 to this one called register V0. V0 is actually number 2, right? And load immediate data. So you load a 10 over there and then call system call. So actually you are calling function 10, something like that. Calling function 10. And what is function 10? Function 10 is the finish of the program. You will just finish your program. That's your function 10. Okay, here are the system call. You have function 1, 2, 3, 4, 5. Is basically it's a print read. So in your Java, you had the system.out.print. You have system.out.printf. You have system in the scanner. It actually using the system call. And actually it's I/O functions basically. And 10 is for exit or program. Okay, so for your C language, you have printf, those kind of functions. Now you need to use a system call. And you need to prepare your data and prepare your number of the function call, like the number 10 for exit, before you actually call a system call. So right here we have a simple program. It's called print_s. Okay. So print_s actually right here we have a data segment and we have str ASCII with 0. This one ASCII with 0. So this one actually is this one terminate with the /0. So what this is actually char and then str equals this. So these two are equivalent. Is that okay? So this is ATR become a label over here, right? And this is the string it talk about, and it has a Z terminate with 0. If no D, there is no terminate 0. No D, it will become character str. Okay, okay. Here you. I missed this sign. Okay.
So that prints out the answer equals 5.
TH. Okay, whatever. So if there's no G, actually is declared in like this, an array of character. And if there's a ASCII G, actually declared a string like this. Okay, so that's the data. That's the data. After that, actually, what we do is we actually load the system call number 4, right? And then actually we load the ages to as an argument to there. So this one is low immediate data. This one is low ages. After that, you call number 4. So this one put into here actually is like loading like a print, right? Number 4 could be like string or something, and then you actually string. You know what I'm saying? This whole thing is just like this. This str being loaded to the argument, like this, right? And number 4 call is actually the print_s, print string, and then you do system call. So that one actually do this. So actually the answer is, and then the next one you call number 1, actually is a print integer or something, okay? And then you put a file over there into as the parameter, and you do call. So this whole call actually, this whole thing actually will, yeah, it will print out the answer is 5. Is that okay?
Mm-hmm.
So that's actually clean this whole thing up. Clean this whole thing up. This line actually give you character str equals the something. Okay. This 2, 3 is actually print string with str. This 3 actually is a print integer with 5. Okay. So 3 segment of it. These 2 are in instruction. This one is in data. So this one is the global data. Okay. So let's look at go back to the previous page for the print. The service code 1 is integer. Service 4 is print string. Okay. That's why invent a C label for you. So here are different system code type. Now let's go to the program print. Okay. So now let's actually try our QtSpim. So first you need to install your QtSpim, right? It's something like this. And then in your disk, you need to create some folder, just like your C program. Say here I have a print, right? I'm sorry. Probably save a print to somewhere else, but that's fine. Let me go into here, right? I actually using my Notepad++, right? And then actually, let me see here. Okay, let me close all. And then I new a file, right? And I save as, here I have print. So here I write print.s. So I write my first print function, right? And instead of getting from scratch, I just copy this whole thing over and put it down here. And the reason why I want to use this one called NoPeta process, as you can see, it actually highlight the label, highlight the directive, highlight the immediate data for you, okay? And you can set the language to S, whatever, okay? You just save a .s file, it will automatically give you the assembly format. Is that okay? You see, it's actually give you quite good format over here. After that, I have this one called my QtSpim, right? I have my QtSpim, and it also comes with the console. Okay, 2 windows. Let me minimize this guy. Okay, and this one is my QtSpim. So now I'm going to load the program and run it. Okay, I written that in my Notepad++. You finish the programming task over here. Come here, you have a file. Then we initiate a no program file. And I actually go to here, go to my print, pick up my print.s. So as you can see right here is the print.s. And the program user text segment look different from yours, but that's fine, don't worry. I will explain that later. But here on the right hand side, you have register. So actually with this, you can actually here, you can do clear the register or reinitialize the simulator and clear the register. Okay. And then again, you load the file because I cleaned the simulator already. Now, here because I have already set some data to my string. So there is in my data segment, I click data, there are some data, and it says that the answer equals. Is that okay? Is that okay? See that? Yeah. So when I click the data, I have the data there. Text will be here. So my program over here, if I say that data, this section is stored. If you want to see it, it is stored in data.
Okay.
And text is on here. Okay, after that, I load it already and click run. Where is it? Wait. Did I save it? Let me do it. Okay, you may miss something. Okay, you may miss something. After system call, let me do one more thing. Let me do one more thing. From here, let me see here. Maybe it's missed something. I probably need to jump back with the return edges. Okay, let me actually put this one back. Okay. And then return to the right edges. And then the text region, let me add 2 more things as well. Text region, let me add 2 more things as well. I want to declare the global name main, so that I know that it's my main function. Right here, actually, I put it here like this. Okay. Let me see. Yeah, should be fine. Let me see. Let me save, okay. So I make some modification, I save all, and go back to here. Because I save all, so what I need to do is like I actually need to abandon whatever I have. So I reset it, and then actually I reinitialize and load again, right? And that's wrong. See? You put now the answer is, but because I actually do not print the file. It actually returned already. So what I make a mistake. So right
you put
here,
a 5?
no, I put a 5, but actually I make a mistake. I actually don't return to the caller. Return the caller means the function already finished. So let me actually save it again. Okay, that terminate the program and then return to the caller. So here, let me actually redo again. Let me clean it. Okay, and actually I reinitialize and load the program again, and then not run. See it? See it?
Mm-hmm.
So you write a program, you set up the data segment, and that declare this. And here I have main, right? So main function starting from here. Okay. So let me actually change this. Give it a space. You won't. It doesn't matter. Actually, it actually doesn't matter if I say this or not. Okay. So here actually, let me actually. I clear it, right? The program clear it, and then I reload it again. Okay. So that's the program. Our first program is. So let's look at this. This one again, I declare a string right here, right? And I declare a global main function, and then I do this, print out the string, and then I do this, print out the value file, and then I return to my caller. So my caller maybe is because I have the QtSpim, so I need to add this over there. Is that okay?
Yeah.
So that actually will finish it running, okay? So that's the first program we try, okay? And then let's look at our slides. So that's what we have. Okay, and here are different system calls. Here are different system calls. Just remember that these are a few I/O functions that you can use, okay? And number 9 is like return the pointer of a block of memory. So that's this one is equivalent to memory allocate. SBRK. Is that okay?
Uh-huh.
You return a. So here you have different print function, but all of these you need to do system call SYSCALL, and there's a memory allocation. So these are basic 10, 11, 12 different functions. But now the first thing, let's look at it. The thing called directive. Directive is a text, that data, that global symbol. Global no E, okay? No BAL, no A, no A, okay? So GLOBL, okay? Symbol. Declare that symbol is global and can be referred from other file. So other program like different .s file can still access it. That's called global symbol. Is that okay?
Uh-huh.
So what's that for? In C language, what's that? In C language, what's that?
Static? Public?
No. It's term. Static is private, okay? Okay? Static is private. So you put that text is actually in your program area. So if you actually do this, if you do that text, right? As I said, that global main, and then main actually is a label here, right? So main actually is the ages. So this one is like main this, right? This is main this, right? So that actually starting whatever instruction is actually declare a main function. And this main function is global. So it actually is turn declare a system and other people can use it. Is that okay? But C language, same thing. If you don't put an extend, it still be an extend. So that part is fine, okay? And then you have the word, you declare some word. So if you write some word, it actually just, if you write some words, that words, 3, no comma, 3, 4, 5, right? And right here, this is a directive. So you just put the data 32 bit for 3, 32 bit for 4, 32 bit for 5. And if there I put a label A, let me use a red color, label A. That means what? That actually give you this. Is that okay?
Mm-hmm.
If I write something called A column dot word is the data type declaration 345. I put 345 in 3 integer, and that address is a label. It's called A, so it becomes like that. So when later you use the A $2 and then $2 you put a 0 there, it will give you A of 0. That will give you 3. Is that okay? So this is the way to declare an integer array. But word actually is 32-bit. It can be floating point, it can be integer, it can be any 32-bit data, you know, because assembly there is no data type. Half is 16, and byte is for 8-bit. Okay. So it's I should say it's integer, but it actually is integer flow. Half is short or Unicode character Unicode 16-bit UTF. Byte is a single character. Okay, in C language. So you also have the ASCII string that do not terminate, do not null terminate. You don't have backslash O for there. ASCII Z is with 0. That one is a string. So this the first one is actually a character or a array of character. Second one is a string. It's a string. These two are different. Is that okay?
Mm-hmm.
So basically, this one and this one are used for data type, integer flow, short character, something like that. And you have the flow. You can declare flow. You can declare double. You can declare space. Space means I reserve some space, but I do not use it. Okay. And align n actually is more for structure. So we will see it when we meet it. The next program is called hello world. Hello.s. So this one actually you declare a segment data with hello. So basically this one is called character MSG equals hello whatever backslash n. So backslash n is similar to C language. And your main program is over here, so it actually is like integer main, right? Load the message to address to A0. Set the function call to 4. That's print string. So actually, just do print S with my MSG. That's it, and then return to the caller. Okay, so that's the hello program. So let's look at the hello program again. It's similar to the previous one actually. So this one actually, you can do nothing, just do reinitiate and no file. Go back to here. Just try stay organized like me. We look at the data first. There's a hello assembly. Actually, I changed the program. It's not hello. Let me load it. The one I changed it. So let me change it to this one, go hello. Okay, this one has a hello. And then, so it's a hello MIPS something. And your program is like here, so that's wrong. See, hello assembly. So right here, if I change my word, instead of doing this, I use tab T. Okay, see how it goes. And then again, right here, you just do initiate and load and run. You see, you get a tab in between. Okay, so that's what it is. And then here it shows you the environment of the QtSpim. Here show you the environment of QtSpim, and we know that. So the next one discussion. Labels. Label is like a variable ID or your function address. So you mark the address of some memory location. So you can jump to, you can use that to pass as an address for other people, like the MSG, right? So label is a pointer or a address. Directive will tell people I try to declare an integer, or I try to actually declare a string or something. Okay, that data.text is a directive to assembler, telling them, okay, right here I have the instruction section, or I have the data section. Memory arrangement that actually help people to arrange the structure or something else. So here are the different pointers function. We know that. And then running Qt. So running QtSpim is a software that will help you to simulate the execution of MISP assembly language. Okay, whatever. And then the next one, you actually start with a Notepad++, write a program in MISP assembly, and then you can use a MISP assembler. QtSpim is not an assembler. It won't generate the object code for you. QtSpim is a virtual machine. It's a virtual machine help you to run it. So it's a little bit like Java virtual machine, it will run for you. Or a little bit like a Python interpreter. It is not something like C language, it will generate some .o code for you. Whether it has the assembler function or not, I have to check. I'm not really up to that point yet, okay? And here is like your program. Your program look like this, okay? The one we write for MSG, the print out the hello is like this. And some of the code got substituted. You know, if you look at this hello program, in your Qt is different from what we wrote here. What we write is like here, more readable. The one actually show the real assembly language used in real assembly being written by Qt is different. Run by Qt is different. And that's because we have something called pseudo instruction. And that's something we will cover later. Okay, we have pseudo instruction. That is something we will cover later. QtSpim windows divide into different sections. And now we know is a register button across the text tab data. So here you have the whole Qt environment. You can load file from there. You can reinitialize and load file. You have the save log. After your execution, you can save it. You can clear the register. You can run simulation. You can step in step by step. So step in is like, in this program, I finished, right? But I actually can clear register and reinitialize, but you go back the same program and actually run. Oh, I'm sorry, I actually lost it. I should actually load file and reinitialize the hello. And after that, I run it once. After I finish, I can actually clear the register, and everything program counter go back to 0, and you can rerun it. Wait, I clear the register. Let me see. Let me reload and hello. I may hit the wrong button. Let me check. No, not register. I should clear the register. After you clear the register, this one is okay. Not this one. This one actually totally dump the program. This one actually is like we clear the register, and you can rerun again. So clear register, rerun again. You know, you actually run 2 times, 3 times. Okay, clear register, run again, and you can also clear register, step in, step by step, one by one, run. Okay, one by one, run. Okay, that actually for clear register and run. Okay. And the next one is called pseudo instruction. Pseudo instruction, we will discuss it next time, okay? So today's homework would be you download the QtSpim. If possible, you print something like ASCII art, small ASCII art or something. Try to print it. Is that okay? Give you some idea of what the QtSpim is. Okay, that's your homework for today. Is that okay? Okay, bye now.
Bye.